Hey, what's up, guys? Today's question is sort colors. So for this question, we can solve this question by three types of steps. So first is a simple step. Either use the normal inbuilt function nums dot sorry begin nums dot and wait for a second, wait for a while. We will surely do the what is the uh, backend sorting function we are using in this sort type. We are using the merge sort right now in this. So here is the normal function, inbuilt function, and in the backend it uses the merge sort. So it always work normally. There is no issue. Yeah, it's working. So to solve this question, at first we have to understand the brute force, what's the issue and what was the solution for it. So for the brute force, we use the int I is equal to 0. We have to use the two loops. Int j is equals to I plus 1. You are asking, have a doubt like why we are reducing -1 here, because when the initial when the pointer j goes to the last index of the nums, it will initialize in I plus 1. We get the garbage value or get the error that way. So that's why we reducing -1 there, and then also increasing my I plus 1, because we are checking the value uh, of the two pointers just after the first pointer. Let me clear with my words, like j nums dot size, yeah, and j plus plus. So in this, if nums i is greater than the nums j, we surely do it like this also. I'm sure. And nums i is greater than or equal to nums j. So no, sorry, yeah, if nums j is greater than or equal to nums j, we have to swap the nums j and nums I. Swap nums I and nums j. So like that, and that's all. We check it. What's the issue? 221100. 1 second. Sorry. Normally it's working fine. Yeah, it's working fine. It is a brute force. To tackle the brute force approach, we use the merge sort. Initially, we are using the normal inbuilt function on like sort nums begin to nums end. So in the back end, it uses the same merge sort technique to solve this problem. So to solve this problem, we are going through the merge sort. So merge sort, we are giving the attributes like int size is equals to nums dot size. We are initializing the left value 0 and the right value what size -1 right away. Yeah, then after that we have to make the function for the merge sort as well. So while coding, I will let you know what is a merge sort. Merge sort follows the divide and conquer technique, so in which we divide and divide again and again until which condition? Until the pointer meet at the same point. So it will check out, it uses your two constant space, vector space, to check the value it is greater than or not, and then it will swap the value as well. So if the other condition, time of the time complexity. So for the time complexity, it is the inverse of the space complexity. So in time complexity is the inverse of the space complexity. So in this complexity part, in the brute force condition, it uses the time complexity of n square, where to tackle this issue we use the constant space. So in the constant space, if we are using the space, we can decrease the time complexity of merge sort. Time complexity is n log n. So what is the base condition for the merge sorter to stop the this function? In in the past I have let you know, like if left is greater than equal to right, we will return. If the left pointer is greater than equal to right pointer, it was always return the there is no use of the pointers as well as the vectors. So we use the merge sort. Again we will divide again and again until we reach to the when the pointer left is greater than equal to right, it will return. It will come out from the loop and give the return value. Merge sort, it will sort the proper nums properly, and we have to divide. Like we have to calculate the mid part, left plus right minus left. So we have to give two things, nums left, we have to divide again and again. So up to which we have to divide to the mid part. So to the mid part we have to mid part, and again we use the sorting function for the nums to from the index mid plus 1 to the right part, no issue. And we have to use the merger. We have to merge again and again. Like we at first we are conquering all the array again and again. Then after that there are certain point where we have two elements. We have to compare two elements if it is greater than or less than. If it is after checking the condition and calculating after all the things, and we have to again merge the all the vectors as well. So we have to pass the nums, we have to pass the left, mid as well as the right. That's all. Then we have to make the another function that will check the condition, do the sorting, as well as use the constant space for the to calculate all the things in the calculate all the things in this function. We get the sorted part. So here is a merge vector so we have to make the two vectors. So at first we have to take out what is the space used in the vectors. We have to make the two vectors. What is the space for the, what is the size of the two vectors? So for the two vectors, let's say n1. For the space, what is the space used in the vector? Amount of space is used in the vector, amount of size. So we are taking minus left. And minus left plus 1, and enter right n2 right to mid. I think it's worked. So we have to make the two vectors, vector with a constant space of n1 and n2. Let's say u1 is n1, and the function u2 and u also should be, yeah, here we go. Then vector u and v. Then after to what we have to do, we have taken two, we have to make the two spaces size, and we have to make the vector as well. So yeah, we have to initialize the value of all the nums in the u and v as well. So for doing so, we are going to the u2 n1 and I++. So here we initializing ui with the value of array I. What is array I? Is the nums I, right? Nums I. But we have to give the value of left plus I, because we don't know nums I is the nums I will take the actual value of this part, but we are dividing again and again, so we have to take the left initialized part we are given getting from the after dividing the actual nums. So here we left plus I we are getting again, yeah. Then we have to make the same function as well again. Here for the v1, for the v1, here we go, vi is the right. No, there is no uses of the right. We will see nums mid I, because for the left we have an array like this. We have a left here add 2, and we have go to the mid. Then after mid we have to get here is the u part and here is the v part. So for the v part, mid plus I, and then yeah, then again we have to go through the here we ui and vi, n1 n2 we have done ui vi. Now we have to check the condition as well as do the sorting part, swapping all the values. So we have to initialize three variables, and I is equals to 0, and j is equals to 0, int k is equals to left. Why left? Because like after checking the value in the u and v, we are to initialize all the values in the nums part only, where the nums part use the initializer use the pointer k. So if I is less than n1 and j is less than n2, so if u I is greater than the vj, like this. No, sorry. If ui is greater than vj, we are initializing array nums k with value ui and increase the value of I++. Else nums k only with the value vj. Now we have to increase the k++ as well. Yeah. So here we done the sorting part, but what happened if I is left out to some values? So individually we have to complete it, because if the one of the condition is false, we have not able to iterate full values of the nums. So we have to individually calculate is the I is less than n1. So I is less than n1. We initialize array k, sorry, nums k is equals to nums I ui, sorry, ui. Here we go while, sorry, we have to increase the value as well. When j is less than n2, nums k is equals to vj and j plus plus k plus plus. That's all. Let's see if there is any syntax error. It will sort all the values in the function. Yeah, here's the error. Overflow issue. Let's see. Left to mid plus 1 to right, and here we go with the value. Then after it will here come mid plus 1, mid minus left. All things are good. Yeah, here we go. We have completed this question as well. No issue. Thank you.